Welcome friends in the next session of MOOCs on computer vision. In this session we will learn various components of computer vision system. There are three main components of computer vision system. The first is camera. It's a basic image sensor through which photons are captured. Second component of computer vision system is the computer interface. It is very much essential to carry the information from the camera to the processor. And third component, which is the most significant component of the system, is the processing unit, which we simply call that as a computer or any specialized hardware which is used to process the given information. So let's discuss one by one. We start with the camera. It's a basic sensing element. There are many categories of cameras available like Vidicon, CCD, CMOS. Vidicon is an old analog technique which concept was used in the television. It is basically a television is in a reverse way. Nowadays we all are using CCD and CMOS image sensors. So CCDs and CMOS uses arrays of sensors and the light falls on those array of sensors. That light got converted into electric charge and that charge is propagated to the next step. There are two types of semiconductor pixel sensors which are either active or passive. So either of the camera, let it be a CCD or CMOS, it contains the pixel sensors through which light is captured. So there are two categories of these pixel sensors called as active and passive. The passive pixel sensors is shown on the left of this side. There is an incident light. These photons are incident on these two plates and the charge gets generated. This developed charge is carried from this point to the columbus. There is a switch called transistor through which the charge gets traveled to the columbus. Such arrangement of pixel sensors is called as passive pixel sensor. On the contrary, in active pixel sensor, you'll find when the light gets fault on the plates, the charge is generated and this charge is passed to the columbus through VDD and through select button. So we have a special control over here called select. There is a provision that the given charge can be applied to the columbus or not as per the convenience. Also, the entire charge can be blanked or made to zero based by pressing the reset button. So in active pixel sensor, there is a provision of reset and select. Select button allows you to carry that charge, that information to the columbus as per the convenience. While in passive pixel sensor, there is no such arrangement. Every information generated, every charge created is compulsorily propagated to the columbus. Let's understand the basics of charge coupled device sensor. You'll find in this slide there are small squares shown in some gray color. These gray squares are nothing but the pixel sensors. You'll find these sensors over here. These pixel sensors collect the photons, the lights gets incident on the sensors and this charge generated out of the process is put up on this vertical transport register. All these squares, which we call it as charge buckets, all these buckets will collect the charge and this charge is propagated via vertical transport registers towards a horizontal transport register. So in the next cycle, all buckets are poured on horizontal transport register and the accumulative signal is traveled to a signal conditioning circuit. Signal conditioning circuit is either a amplification or a suitable processing technique that is used as per the demand. The control inputs, they provide useful signals which will manipulate the amount of charge that is further propagated to the signal conditioning circuit and finally we get the video output. This concept is based in the CCD sensor. Based on the applications, there are special cameras available, and as per the application of the individual project, one can choose a specific camera. Like there are certain cameras which are of high resolution, there are certain cameras which can capture even a low light level, so there won't be any requirement of contrast enhancement, and it improves the efficiency, while some cameras are infrared cameras. So based on the need of the project, one has to select the camera and use it appropriately. Second component of computer vision system is computer interface. It's a very important component through which the information from the camera, the charge from the camera, which generates the video output, that video output is passed through this computer interface through a processor or to a computing machine. So the computer interface basically converts analog camera signal into digital numbers. Computer interfaces are widely known as frame grabbers. Nowadays, the cameras are available where the frame grabbers are inbuilt. The computer interfaces are inbuilt in the camera. So you just need to plug in your camera to your processing unit and you can start developing your own computer vision project or application. As you can see in this image on the bottom of the screen, input video is given to a signal conditioning circuit. The output of signal conditioning circuit is fine, is given to A to D converter, where analog signal is converted into digital numbers. Next, we have a lookup table where predefined levels of digital numbers are available, and every converted analog signal into a digital number, every digital number is further converted into a nearby predefined steps. The required output from the lookup table, which are predefined levels, are stored in the image memory, and a computer interface accesses this image memory and gives the data to a computer. There are some control signals which are given to signal conditioning circuit, A to D converter and lookup table to adjust the gain and other parameters. The third component of computer vision system is the main processing of a image or a video. Nowadays, there are special hardware and software systems are available which can process any image or any video. Most of the processing happens in the software, and very few techniques they are migrated into the hardware. Lot of coding formats are available nowadays like JPEG, MPEG, Mini for audio and video. We have the good languages with the help of which one can develop the algorithm for any computer vision application like C, C++, Java. There are some special engineering softwares available which are MATLAB, it's a matrix laboratory, OpenCV software, it's an open source language which is especially developed a computer vision algorithms, and it is widely used nowadays in most of the applications and projects. Also, there are many hardwares available like Raspberry Pi. There are some hardwares from analog devices called blackfin processors. So these blackfin processors are especially developed for application development of computer vision. So in processing of an image, most of the components are done in the software and very few components are transferred to the hardware. So in combination of hardware and software, a typical computer vision project is being built. So friends, in this session we learned what are the main components of computer vision system, which are camera, which is a basic image sensor which collects the light and converts that light into a suitable electric signal. Second component of computer vision system is the frame grabber or computer interface. This is a very essential component which is a link between your camera and the main processing unit. Nowadays, there are many cameras which have inbuilt computer interface or frame grabber. And the third component of computer vision system, which is a very significant, and that is the processing unit. It can be your software or it can be your hardware, with the help of which any algorithm is developed and any suitable task which is meant for is accomplished. Friends, that's all for this session. Thank you. Thank you very much.